Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful for the international entrance or any competitive exam you're preparing for. In addition to this one, India level JE Advanced, JE Mains for engineering entrance for IITs and NITs, and NEET chemistry for medical entrance examination. Telangana and Andhra Pradesh for the MSET entrance examination for engineering stream. In addition to all this, if anybody aspiring for the government examination where general studies question paper will be there, that is common for whatever the exam you are writing. In that, general science content will be there. The topic what we are discussing is very much fetching for that kind of session. Let's enter into our today's session. Explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, we need to assign the name for the given compound. It is the kind you can find two ring systems which are connected with one common carbon. Whatever compound combined with the one carbon, that is said to be spiro. So here spiroiam, this ring is saying spiroiam, right? So because of this kind of arrangement in the name, first of all we have to start with the spiro, right? So there is a slight difference between bicyclic system and spiro compound. Bicyclic systems are called fused ring systems where two carbon atoms are joining two rings, but in case of spiro, one carbon is joining two ring system. That is the distinctive factor in between spiro and bicyclic ring systems. So that whenever only one carbon you can notice in between two ring system, that you can say spiro. And in this spiro compound, one side you can notice 1, 2, 3, 4 carbon atoms. In either side also we can find 1, 2, 3, 4 carbon atoms. That's why within the square bracket, let me mention 4, 4. 4, 4 denotes what? 4 carbons on one ring system and another 4 carbons on another ring system. So that 4, 4 is mentioned. And here, being it is the kind of 9 carbon chain, if you notice, 1, 2, 3, 4, fifth carbon bridged one, sixth, seventh, eighth, ninth. This is the entire system with the 9 carbon atoms. So that the parent skeleton will become nonane. This is the way. Spiro 4, 4 nonane is the complete name for this spiro compound as per the IUPAC protocol. For this compound, spiro 4, 4 nonane is the IUPAC nomenclature. Fine. Move on to here is the again definition for the spiro compound. In organic chemistry, spiro compounds are the compounds which are at least two ring systems must be present and they should joined by one common carbon atom. This is the way you can notice the simplistic sample regarding the spiro compound. One of the side you can find 6 carbon and another side 5 carbon, both are fused with a common carbon. This carbon remains common for two ring systems. This is called a spiro one, right? So move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Aqueous nickel to sulfate is used as the electrolyte to electroplate a piece of steel with a nickel. Which materials are used as a negative electrode and a positive electrode? First of all, let me explain what is meant by the technique called electroplating. This is a method we can call it electroplating. Electroplating is nothing but any object, so especially any metal having natural susceptibility for corrosion, right? In order to avoid the corrosion process, we need to cover that compound with the suitable ingredients on its surface. We have different methods for that kind of protection. Okay, coating of one metal over another metal in the presence of electrical current is said to be electroplating. One metal is taken is iron. On its surface, you are coating with the nickel so that it is the process of electroplating with the nickel, right? Steel is the kind of iron only. Iron is the main object, major object used worldwide for the constructional purpose and also the kind of industrial equipments, machinery, and also bridges, railings, building constructions. Everywhere we have the application in the railways. That is also made of railway system is also that railway tracks and railway bogies also made up of steel, right? So that everywhere we can find the steel as the major application worldwide, and nickel is the kind of metal having passivity. Nickel is the metal having passivity. Passivity is nothing but resistivity towards the corrosion is called passivity. That is the exceptional property offered for few metals. Among nickel is one of them, right? So that electroplating is the kind of technique where avoiding the corrosion of steel in the presence of nickel by applying the electrical current. In order to do this process, what will be the negative electrode, what will be the positive electrode, we need to identify. So among these many options, B option will be said to be correct, and the negative electrode must be nickel metal. Pure nickel can be taken, and the positive electrode is a steel on whose surface you want to get the protection, that is said to be a kind of positive electrode. This is the way we can answer. Let's see a detailed explanation regarding this kind of electroplating process. In order to go for electroplating process, let me take metal rod, nickel metal rod over there. That is pure nickel taken as an anode over there. Nickel is the anode, a solid nickel rod was taken. And then this a liquid was poured. That liquid is made up of what? Electrolyte. Liquid is said to be electrolyte, and it is made up of nickel sulfate. Nickel sulfate is electrolyte taken in this container. And the cation is made up of spoon. Whose surface you want to protect, that to be taken. I want to protect the spoon, that's why spoon was taken as the cathode over here. So simply you can say steel, or else any object on whose surface you are taking this protection. So simply I'm taking spoon for your kind understanding. So cathode will be a spoon made up of steel, anode will be the pure nickel metal will be taken, electrolyte is made up of nickel sulfate. So this is about the set of experiment where electroplating. Why we are saying electroplating? We are applying the electrical current. Whenever electrical current is applied, metallic nickel will be dissolved, and whatever nickel plus 2 is there, the nickel plus 2 accept the electrons and will deposited on the surface of this cathode, which is the object taking spoon, so that nickel slowly covering on the surface of this kind of object whichever taken as the cathode, so that a layer formed with the nickel on the surface of the spoon, which is called a electroplating. In the presence of electrical current, nickel coated on the surface of the spoon called electroplating. That is available in the option number B. For question number 2, option number B will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2020 question paper, and it is a kind of paper 1, right? 5 ml of 0.1 molar oxalic acid solution taken on a conical flask, titrated against sodium hydroxide from a burette using phenolphthalein indicator. The volume of NaOH required for the appearance of permanent faint pink color is tabulated below. For 5 experiments, what is the concentration in molarity of NaOH solution? Right, this is a kind of volumetric analysis we are going with, and simply we can say oxalic acid versus NaOH acid base titration it will be, right? But it is oxalic acid is the kind of 2 equivalent, you can find 2H plus. NaOH is mono acidic, we can say 1 OH minus it able to release. That means what? For one oxalic acid we require 2 NaOH molecule, because here we have 2 dibasic, here we have monoacidic. That's the reason why there is a kind of acid-base titration. Simply, we are taking the formula that is M1V1 is equal to M2V2. Using that one of the known concentration, always the purpose of titration is, the initial purpose of titration is fundamental is one unknown concentrated solution will be taken. By titrating against known concentrated, you can get the concentration of unknown solution. That is the purpose of titration. Here also concentration of NaOH to be determined by taking the values, sodium hydroxide values are there, and moreover it is a clear cut indication that in all these experiments, though you're adding NaOH, its value is not changed. That indicates it is the required NaOH consumed for the neutralization of oxalic acid. So that this is very clear. Amount of sodium hydroxide consumed for this oxalic acid neutralization will be 9 ml, right? So from this data, True data says that sodium hydroxide volume consumed will be 9 ml because you are taking oxalic acid in the conical and added with phenolphthalein indicator titrated against NaOH. So that how extent we need NaOH, 9 ml is required for the neutralization reaction. And here the condition is milliequivalent of oxalic acid is equal to milliequivalent of sodium hydroxide. So here formula used is M1V1 is equal to M2V2. V1 volume of oxalic acid consumed will be 5 ml we are consuming, and its concentration is 0.1 molar. 5 ml of 0.1 molar will be taken. Just now we said it able to release 2H plus, so that multiplied with 2. And volume of NaOH consumed for the neutralization will be 9 ml. Molarity we need to identify, that is unknown. That is only intention to be determined. And one will be the equivalent for NaOH. NaOH can release only one OH minus now, so that it is mentioned with one OH minus equivalent. So if you apply all these, what happens? Molarity, what unknown molarity is equal to, this will be 1 by 9. So 1 by 9 is the value. If 1 by 9 is taken, that can be taken into, that can be modified into the decimal points 0.11 molar solution. This is the way you can solve the problem in analytical, and moreover it is the volumetric analysis problem, we can say. For question number 3, 0.11 molar solution is the correct answer. Move on to question number 4. Question number 4 is collected from the organic chemistry part, where it is the kind of benzene ring containing these many substituents on that, and subjected to the simple addition of concentrated sulfuric acid. Whenever sulfuric acid is added, there is a kind of here benzene ring. Another benzene ring is there. Simply we can say phenyl. Here another phenyl. Here another phenyl is there. This is the part where reactivity is occurred in presence of the suitable reagent. Ester, upon treating with concentrated sulfuric acid, it is a kind of acid catalyzed hydrolysis of ester. Ester will be hydrolyzed, so that a new product will be formed. Being it is the kind of hindered, that means already substituted one, we are not supposed to expect the carboxylic acid as the final product. Rather, it will rearrange itself to give another new product over here. That new product will be compound Q, right? In the following reaction, compound Q is obtained from compound P via ionic intermediate. Here the matter ionic intermediate we have to trace out. Let's see how can we achieve the compound Q starting from P. In order to get that one, the starting material will be taken simply. pH denotes what? Phenyl. Phenyl means a C6H5, means another benzene ring only. Here you can find another benzene, here another benzene. Triphenyl groups are present, and here ester functional group is present. C double bond OCH3 is called ester. It is the acid derivative. Whenever ester functional group is present, it is treated with concentrated sulfuric acid. Sulfuric acid is the acidic medium used to cut out this ester linkage. Ester linkage will be broken, so that carbon will acquire positive, oxygen will acquire negative, and carbocation, acetyl carbocation will be generated. They are asking for ionic intermediate, so that we need to mention this one. Ionic intermediate is need to be mentioned. So this acetyl carbocation will be formed. Actually, under normal conditions, what it will do, it will accept the OH minus from the water, so that subsequently final product will be carboxylic acid. In general, we will get ester hydrolysis always gives rise to the carboxylic acid. But what happens here, within the reaction, within the molecule, there is a certain kind of rearrangement is possible. This carbocation will bind with the adjacent benzene ring, so that there is a kind of stable cyclic product, we can say double bond O. Cyclic ketone will be generated, and in specific we can say fused cyclic ketone will be generated. This is a kind of fused system. So many rings are in contact. So that fused ring system will be there, and there is a kind of double bond O. Double bond O is called what? Ketone. So fused ketone will be generated as the final product. The question is, if this is the case, So if Q is formed, what is the degree of unsaturation? This is the actual question. Being it is the organic chemistry part, but there is a kind of a physical chemistry focus on this. Degree of unsaturation means we have to go for mathematical part over here. In order to get that kind of degree of unsaturation in the given compound, there is a formula. This is collected from the Liber text. Degree of unsaturation is equal to 2 carbon plus 2 n plus n minus x minus h by 2. Carbon denotes what? Number of carbon atoms present in the given compound. And N means what? Number of nitrogens present in the compound. X means what? Number of halogens, either fluoro, chloro, bromo, iodo can be taken into the consideration. H for hydrogen atoms present in the compound, and upon 2 can be mentioned. 2C plus 2 plus N minus X minus H upon 2. This will be the kind of formula required for the calculation of degree of unsaturation. For this compound, if this is the formula, let me count the carbon atoms. Each benzene contributes 6 carbons, no? 6 plus 6, 12 carbons will be there. 12 plus 12, because here also we have 2 benzene rings again. PH means 2 benzene rings. 12 plus 12, 24. 24 plus here one corner carbon is there, too, so that 25. Total possible carbon atoms are 25, and already we have 2C, no? So that let me multiply with 2. 2 into 25 will be taken, plus 2 will be there, nitrogen. If you observe the compound, we can't find any nitrogen, so that exclude this X. No halogen is also present, so that exclude this term also. There is no question of oxygen in the formula, so that need not to mention oxygen atoms. And only the thing is hydrogen. We need to count hydrogens. If benzene is there, that means phenyl is there, that is C6H5. That means phenyl contributes 5 hydrogens. Another phenyl, 5 hydrogens, 5 plus 5, 10 will be there. 11, 12 hydrogens, 13, 14, 15, 16. Total 16 hydrogens are present in the given aromatic compound. 16 hydrogens are mentioned over there. And here we have denominator term 2, so that divide with 2. 2 into 25 plus 2 minus 16 over 2. This is the formula for degree of unsaturation. 2 multiplied with 25, 50. 50 plus 2, 52. When 52 is taken, 52 from 50 to 16 will be subtracted. 36 the value will be, and that should be divided with 2. 36 divided with the 2, the value will be 18. Degree of unsaturation for the given compound will be 18. This is the way we can go for the calculation. First of all, we have to identify what will be the product over here, what intermediate we will get. So if this is the actual product of what we are expecting, then only it is possible to go for degree of unsaturation. Just simply we have to put on the formula, so that final answer will come. But only the main focused part here is what product actually we will gain. If that is the correct answer, obviously we will get degree of unsaturation in the correct dimension. So that we need to focus on more reagent chemistry, so that kind of route, what way the reaction is proceeding and what product we will expect, that will come into the picture, so that we can go for further analysis like this, right? For question number 4, 18 will be the correct answer. Degree of unsaturation is calculated, right? Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College lecturer entrance examination. Which of the following is the correct Helmholtz equation? Helmholtz gives free energy, internal energy, entropy, enthalpy. All these are the terms which related with the thermodynamics. Okay. Helmholtz equation is given by delta E is equal to delta A plus T delta S. This is the equation correctly represents this Helmholtz. So let's get the perfect definition, what detailed explanation for this one. Delta E is equal to delta A plus T delta S. Delta E denotes what? Energy difference, del. So here the symbol del indicates change in the energy from initial to final energy. So if the reactant is there, initial energy will be there. After the reaction, certain extent of energy transformation you can notice. So the difference in the energy is mentioned with the del. the symbol del. So this del indicates the larger difference. And if we are taking do, a small d alphabet, in alphabet small d, that is do we can pronounce. And do e, if mentioned, that indicates the small difference in the energies. Here del E is mentioned, that indicates what? Larger change in the energy. So this larger change in the energy is equal to del A. A denotes what? Free energy. So here Gibbs free energy will be there, and this is Helmholtz free energy. A is del A is the Helmholtz free energy difference. Del represents change in the energy, initial energy to final energy, how it will be changed. Okay, free energy. And T denotes what? Temperature. T for temperature. Delta S means what? Change in the entropy. Entropy means what? Measure of disorderness. And if that is the case, larger difference, you can notice del S we have to mention. The entire equation for the Helmholtz will be del E is equal to del A plus T del S. This is the way you can clearly mention. And let's see what Helmholtz equation actually. Helmholtz equation named after the Hermann von Helmholtz. So this is the kind of equation derived from the physical chemistry linear partial differential equation. This is the Laplacian amplitude and wave number associated with the equation. So Laplacian satisfied with this amplitude and wave nature of the particle also satisfied by means of this Helmholtz equation. Helmholtz equation is also the eigenvalue equation. This is also the part of eigen equation, eigenvalues related with the quantum chemistry. The Helmholtz differential equation can be solved by the separation of variables in only 11 coordinated system. So it is confined to the 11 coordinated system. In that, we can get the solution for the Helmholtz equation. Simply, it is represented with del E is equal to del A plus T del S. This is the way question number 5 will be answered. Fourth one is the correct answer. Move on to question number 6. Question number 6 is given from the kind of what we can say, it is the kind of reaction where it is a kind of chemical kinetics we can say, because how the reaction is proceeding in accordance with the time matters. That's why we can say it is the chemical kinetics, right? So graphical representation is provided. Let's go with the data provided. Which profile in the plot does best represent each of the concentrations of reactant A, intermediate I, final product B, and the total concentration A naught is equal to A plus I plus B for the consecutive reaction. Consecutive reaction means a kind of series of reactions, A further converted into I, further converted into B. So simply it is represented like this. A means what? A reactant species taken, I for intermediate formed within the reaction. After certain time period, intermediate will be formed and finally turned into a product, B for product. So if this is the case, this is the case. In this graph, so many curvatures are provided. All these curvatures belongs to one particular instance among all what mentioned, like a reactant, intermediate, final product, and concentration of these many are coexisted. Okay, so in that case, this graph, first of all, we have to look about what is the x coordinate term and what is y coordinate term. X coordinate is mentioned with the reaction time. Y coordinate we can see concentration. Change in the concentration will be taken. So it is very fundamental that initially what will be existing, initially the existence of reactants only possible. Based on that only we can point out this entire graphical representation, right? So here, first let's see correct answer. Later we will go for the explanation part. So according to this graph, the correct answer will be P denotes A naught and Q denotes A, R denotes I, S denotes B, and all are mentioned in the square bracket. That means concentrations, right? So concentrations of all these components are mentioned over here. Let's see how can we justify this. In order to explain this graph, here time is very important factor, being it is a kind of chemical kinetics. In what way reaction changes according to the time. So as the time passes, how the reactant converted into intermediate, intermediate converted into product, and how they are coexisting at particular instance. Everything depends upon the time, so that we can say it is the kinetics. right? Initially, everybody aware that initially only the possibility of reactants, right? Reactant only existing, so that initially there is a provision for the existence of Q. So if you see time, so almost near to zero time means at the instance where we are starting the reaction, there you can find Q. So that Q is nothing but reactants. It's very clear. Q is nothing but reactants. So after, for example, we are moving towards half an hour. After half an hour, for example, what happens? Certain extent of reactant is converted into some other new kind of product, which is called intermediate. Not exactly final product, but it is the kind of in between, which is called what? Intermediate. After certain amount of time, there is a formation of intermediate is possible. So if you see this, after Q you can find R over here. That R is for what? R means what? Intermediate concentration, right? So finally, after the intermediate formation, again you are waiting for some more time. After certain amount of time, there is a conclusion of the reaction. That means reaction got completed. If the reaction completed, you can expect the product over here. The product is mentioned with the product, the after R, the expected component will be product, no? So that we can say S is the product. Thus S product is given with the B. S product is given with the B. So during this kind of reaction, P is mentioned over there. At this instance of P, there is a certain amount of reactant will be there, and some intermediate compound is generated, and certain extent of product is also formed. There is a coexistence of reactant, intermediate, and a product together. So that is called P. Okay. So here during the entire time period, together coexistence of A, I, and B are possible. So these concentrations are mentioned with A naught. So that is called P. So this P denotes what? There is a kind of coexistence of reactant, intermediate, and product. This is the way we can mention, so that the entire representation is clearly mentioned in the option number 4. For question number 6, option number 4 is the correct answer. By this, we completed the entire session. So that I'm requesting you to like the channel, comment what part is really important for you, and share with these parents who are seriously preparing for the examination. Subscribe the channel to receive more such updates in the near future. And thank you very much for your patient listening. Thank you, one and all.